are sometimes considered a binary system because the barycenter of their orbits does not lie within either body. The plains on Pluto's surface are composed of more than 98% nitrogen gas, ice, with traces of methane and carbon monoxide. Nitrogen and carbon monoxide are most abundant on the anti-Charon face of Pluto, whereas methane is most abundant near 300 degrees east. The mountains are made of water ice. Pluto's surface is quite varied, with large differences in both brightness and color. Pluto is one of the most contrastive bodies in the solar system, with as much contrast as Saturn's moon, Iapetus. The color varies from charcoal black to dark orange or white. Pluto's color is more similar to that of Io, with slightly more orange and significantly less red than Mars. Notable geographical features include Tombog Regio, or the heart, a large bright area on the side opposite Charon, Cthulhu Macula, or the whale, a large dark area on the trailing hemisphere, and the brass knuckles, a series of equatorial dark areas on the leading hemisphere. Sputnik Planitia, the western lobe of the heart, is a 1,000 observation with Charon allowed scientists to establish Pluto's diameter more accurately, whereas the invention of adaptive optics allowed them to determine its shape more accurately. With less than 0.2 lunar masses, Pluto is much less massive than the terrestrial planets, and also less massive than 7 moons: Ganymede, Titan, Callisto, Io, the Moon, Europa, and Triton. The mass is much less than that thought before Charon was discovered. Pluto is more than twice the diameter and a dozen times the masses of Ceres, the largest object in the asteroid belt. It is less massive than the dwarf planet Eris, a trans-Neptunian object discovered in 2005. Though Pluto has a larger diameter of 2,376 kilometers compared to Eris' approximate diameter of 2,326 kilometers. Determination of Pluto's size have been complicated by its atmosphere and hydrocarbon haze. In March 2014, two scientists published findings regarding methane mixing ratios in Pluto's atmosphere consistent with a Plutonian diameter greater than 2,360 kilometers, with a best guess of 2,368 kilometers. On July the 13th, 2015, images from NASA's New Horizons mission, a long-range reconnaissance imager, along with data from the other instruments, determined Pluto's diameter to be 2,370 kilometers, or 1,470 miles, which was later revisited to 1,474 miles. Pluto has a tenuous atmosphere consisting of nitrogen, methane, and carbon monoxide, which are in equilibrium with their ices on Pluto's surface. According to the measurements by New Horizons, the surface pressure is about 1 Pascal, or roughly 1 million to 100,000 less than Earth's atmospheric pressure. It was initially thought that as Pluto moves away from the Sun, its atmosphere should gradually freeze onto the surface. Studies of New Horizons data and ground-based occultation show that Pluto's atmospheric density increases and that it likely remains gaseous throughout Pluto's orbit. New Horizons observations showed that atmospheric escapes of nitrogen to be 10,000 times less than expected. Alan Stern has contended that even a small increase in Pluto's surface temperature can lead to exponential increases in Pluto's atmospheric density. presence of methane, a powerful greenhouse gas, in Pluto's atmosphere creates a temperature inversion, with the average temperature of its atmosphere tens of degrees warmer than its surface. Though observations by New Horizon have revealed Pluto's upper atmosphere to be far cooler than expected, Pluto's atmosphere is divided into roughly 20 regular spaced haze layers up to 150 kilometers high, thought to be the result of pressure waves created by airflow across Pluto's mountains. Pluto's origin and identity has long puzzled astronomers. One early hypothesis was that Pluto was an escaped moon of Neptune, knocked out of its orbit by Neptune's largest current moon, Triton. This idea was eventually rejected after dynamical studies showed it to be impossible because Pluto never approached Neptune in its orbit. Pluto's true place in the solar system began to reveal itself only in 1992, when astronomers began to find small icy objects beyond Neptune that were similar to Pluto, not only in orbit, but also in size and composition. This trans-Neptunian population is thought to be the source of many short-period comets. Pluto is known to be the largest member of the Kuiper Belt, a stable belt of objects located between 30 and 50 astronomical units from the Sun. As of 2011, surface of the Kuiper Belt to magnitude 21 were nearly completed, and any remaining Pluto-sized objects are expected to be beyond 100 astronomical units from the Sun. Like other Kuiper Belt objects, Pluto shares features with comets. For example, the solar wind is gradually blowing Pluto's surface into space. It has been claimed that if Pluto were placed as near to the Sun as Earth, it would develop a tail, as comets do. This claim has been disputed, with the argument that Pluto's escape velocity is too high for this to happen. It has been proposed that Pluto may have formed as a result of the agglomeration of numerous comets and Kuiper Belt objects. Although Pluto is the largest Kuiper Belt object discovered, Neptune's moon, Triton, which is slightly larger than Pluto, is similar to it both geologically and atmospherically, and is overlapping the Kuiper belt are thought to have been placed in their current positions by interactions with Neptune's migrating resonance. A computer model created in 2004 by Alessandro Morbidelli suggested that the migration of Neptune into the Kuiper belt may have been triggered by the formation of a 1-to-2 resonance between Jupiter and Saturn, which created a gravitational push that propelled both Uranus and Neptune into higher orbits and caused them to switch places, ultimately doubling Neptune's distance from the Sun. The resultant expulsion of objects from the Proto-Kuiper belt could also explain the late heavy bombardment 600 million years after the solar system's formation and the origin of the Jupiter Trojans. It is possible that Pluto had a near-circular orbit around 33 astronomical units from the Sun before Neptune's migration perturbed into a resonant capture. The model of 2004 by Alessandro Morbidelli requires that there were about 1,000 Pluto-sized bodies in the original planetesimal disk, which included Triton and Eris. Pluto's distance from Earth makes its in-depth study and exploration difficult. On July the 14th, 2015, NASA's New Horizons space probe flew through the Pluto system, providing much information about it. Pluto's visual apparent magnitude averages 15.1, brightening to 13.65 at perihelion. To see it, a telescope is required, around 30 centimeters or 12-inch aperture being desirable. It looks star-like and without a visible disk, even in large telescope, because its angular diameter is only 0.11. The earliest maps of Pluto, made in the late 1980s, or brightness maps created from close observations of eclipses by its largest moon, Charon. Observations were made of the change in the total average brightness of the Pluto-Charon system during the eclipses. For example, eclipsing a bright spot on Pluto makes a bigger total brightness change than eclipsing a dark spot. Computer processing of many such observations can be used to create a brightness map. This method can also track changes in brightness over time. Better maps were produced from images taken by the Hubble Space Telescope, which offered higher resolution using a